Okay? Okay, let's first talk about series connection and how it affects the total resistance, the total current, and the voltage. What are the voltage drops or across each of the resistance? Okay, kasi we will be introducing equations on each of them. Okay, so here you have two resistors or two devices in series. So, di ba, both of the devices may kanya-kanya siyang resistance. So, if you place them in series, it will add up. Okay? So, kung tutumbasan mo itong dalawang resistor na 6 ohms, you need to put a single 12 ohms. Kung tutumbasan mo itong tatlong resistor na 6 ohms ang resistance, kailangan mo ng isang 18 ohms resistance. Okay? So, I will assume that makes sense to you, no? That's the equivalent resistance. Okay? Pag sinabi equivalent resistance, kung tutumbasan mo itong series of resistors, ano yung magiging resistance or ohms ng single resistor na ipapalit mo? So here, you have to add up the individual resistances to get the equivalent resistance. Okay? That makes sense naman, di ba? Now, remember, current is the same everywhere else in the circuit, di ba? So this is showing you the formula that you will use to compute for the total current if you're giving with a series circuit. Okay, the current is the same everywhere else. This means that the current flowing through each resistor is equal to the total current. Let's think about it this way, no? You have a water pipe, no? There's water inside, obviously. And then along some way, you put some sand. So obviously the sand represents the resistance, diba? The water, the charges, and the flow of the water reflects is the analogy for the current. If you put more sand, the flow will be slower, diba? I mean, the volume of water flowing across a certain section will be lesser, diba, if you put more sand. However, remember that the rate will be the same all throughout. Kung mabagal siya in all parts. Okay? Hindi lamang dito sa part na ito, but it's slow on all parts of the circuit. Okay? So the flow rate will be uniform all throughout. Ayun yung ibig sabihin dito. Okay? So the total current, if you have a resistor here, and the resistor here, diba, current is the amount of charge flowing across or flowing through a cross section of the wire. So whatever is current flowing through here, it's the same as the one flowing here and the one flowing through here in this wire or in this resistor. Okay, so equal sila sa isa't isa. And yung nadaloy sa resistor, that's also the one flowing through the wire. Okay? So I total, I1, the sub 1 is the current flowing through the resistor number 1, I2 and I3, and so on if you have more resistors. And then the sum of the voltage drops across each resistor is equal to the voltage rating of the battery. So, di ba we had a voltage diagram? So, kung ano man ang nag-gain mo dito na energy, that should be all or spent sa mga electrical load may encounter niya sa external circuit. Okay? So, if the charges will gain, each coulomb of charge will gain 120 joules of energy, dapat maging zero na siya at this point. Mako-consume siya or mata-transform in other forms as it is going, as they are making their way through the external circuit. So, kung 120 joules ito, ang potential gain or a voltage gain, voltage boost, dapat ang sum ng voltage drop here will be 120 volts as well. So, since you already have 40 volts here, the voltage drop here should be 80. The voltage drop here should be 40. You have 12 volts here. The drop should sum up to 12 volts. 3 plus 4, that's 7, 8, 9, 10, 11, 12. So, this should be a 5 volt drop here on that bulb. That means yung rating ng battery should be the summation, equal to the summation of the voltage drops in the or along the external circuit. Okay, so if you add the voltage drop across these resistors, these devices, dapat equal siya doon sa rating ng battery. Remember as well that the greater the resistance of a certain device or resistor, the greater the voltage drop that will also happen across that resistor. So in this case, 7 volts yung drop here. So ito yung may pinakamalaking resistance, di ba? Yung resistor number, we don't have a number. Resistor across point D and or resistor sa between point D and E, as you can see here. Okay, now let's have a mathematical analysis of this series circuit. When we say mathematical analysis, we have to look for the total current of the circuit, the current in the individual or flowing through the individual resistors, R1, R2, and R3, the equivalent resistance of the circuit, the voltage across each of the resistors, so V1, V2, and V3. We have to learn, remember the formula, be familiar with the formula, no? So the current is the same all throughout. The voltage ng battery will be the summation of voltage drops across the across the resistors, and then the equivalent resistance is solved using or by summing up the individual resistances. We should start with the REQ. Okay, now get your calculators and then just simply add these values. So if you add 12 plus 17 plus 12 plus 11, you should be getting 40 ohms. Okay? Afterwards, we get the current. Okay? Simple lang itong computation na to, no? Kasi pag nakuha natin yung total current, yun na din yung current na nagpa-flow, di ba? Dito sa R1. Yun na din yung I2, yun na din ang I3. Same all throughout. Let's use the what was that? The Ohm's law. So I total R equivalent. Let's divide this by the R equivalent. So I will be getting the I total by dividing the voltage rating of the battery, 60 volts, divided by the R equivalent, which is 40 ohms. That will give me a 1.5 amperage of current. So check na ako dito, and then oops, not that one. Here. Now, I have to solve for the voltage drops across R1, R2, and R3. Remember, you would expect na iba-iba, no? Yung voltage drop kasi iba-iba yung resistance nila. Greater voltage drop across resistor na may mas malaking resistance. So, voltage drop across resistor 1, R1. Let's not specify. Sige, if you want to put that one. 1 pala yun, not I. So, I1 is equivalent to the I total, di ba? 1.5 ampere times the 17 ohms of resistance. That will be 25.5 volts. Okay, let's move here. We don't have much space. I2, R2. Voltage drop across R2. What is it? 1.5 amperes, 12 ohms, 18 volts. Across R3, 1.5 I3 times R3, 1.5 ampere, 12 ohms, 16.5 volts. Now, if we will get the addition, dapat maglabas yun na 60 volts. So 18 plus 16.5 plus 25.5 should be equal to 60 volts. 18 plus 16.5 plus 25.5, 60 volts. Yes, so we are correct. Okay? That's yun ibig sabihin ng mathematical analysis. Okay? I'll see you on the next part for the parallel circuit.